Find the complete factorization of p of x equals x cubed minus 2x plus 4. We have previously factored this into linear and irreducible quadratics. We had p of x equals x plus 2 and x squared minus 2x plus 2. And this quadratic here was irreducible in the real numbers. However, now we want the complete factorization, so we'd like to factor this down more in the complex numbers. So to do that, we need to find the zeros of this. And to find the zeros of this, we can either complete the square to solve for x, or we can use the quadratic formula. I personally don't really like using the quadratic formula. It just seems kind of clunky to me. So I'm going to go ahead and complete the square there. We get an x minus 1 squared, and then we have a plus 1 at the end. And we set this equal to 0, and then we can solve for x. So if I subtract 1 from both sides, I have x minus 1 squared equals negative 1. And then I take the square root, and I get x minus 1 equals plus or minus I. And then I add 1 to both sides, and I get x equals 1 plus or minus I. And so those are my two zeros from this quadratic. So now I can go a step further in my factorization, and I have x minus each of my zeros. So 1 plus I, and then I have x minus 1 minus I. And we can leave it like that, or I kind of prefer distributing the negative for each of these. I think it makes it a little bit cleaner. And so distributing that negative, I get x minus 1 minus I, and x minus 1 plus I, distributing this minus and this minus into each of those parentheses.